Okay, last one is regression. So regressions are used to look at trends in data. So we're not looking at a difference, we're looking at, is there a correlation? Is there a relationship? Is this going to be more than just a difference between two things? So usually we use it with continuous variables. In these three categories, they aren't continuous, so we're going to have to find some more data. Luckily, this does come with a continuous variable of the nearest house in meters. So we've got a measurement of meters down here, and we can compare it to both brushtail and ringtail today. I'm just going to do brushtail, but if you've got more than one variable, you can always do a couple more. So if this was your temperature would be your X, and your time would be Y. So let's do that. So I highlighted them both. I only went up to here because these ones don't have a distance. So then I'm going to go to insert, and now I really want to jump on this line graph because I want to find a regression, but actually I'm going to jump onto a scatter plot just to see what the data is doing first. And it does look weird, and at first when I saw this I thought I'd done something wrong. However, yes, this is correct. We just don't have a very strong correlation here, or a very strong, there's not going to be a really good line of best fit. You can see that it's sort of got this slight decrease, I guess. But there's a lot of variation. But if you actually have a look, for 2 meters, we've got 6, 7, 3, 5. It's scattered along here of the number. Okay, you can see probably the average is going down slightly. Yeah. But let's test that strength of that relationship. I can already tell it's going to be pretty weak, but we can test it. So first thing we need to do is select our data points just by clicking. Maybe it's right-clicking. It's right-clicking. Right-clicking on the data points and then going plus. And we're going to add a trend line. So give it a nice little tick, and automatically it's a linear trend line. Now, with your times, just think about what your trend line is going to look like, and what the graphs that we've seen with enzymes actually looks like. It's not a straight line. It kind of goes up then down. Although yours might be flipped because you're doing time, not rate. So the best enzyme is going to have the lowest time. That makes sense. So usually we look at a rate of reaction. You can see it goes up and then down. Ours is going to be inverse, but hopefully, we'll see what our data looks like. All right, trend line. I want to do more options. I feel like it's almost like exponential. Let's try that. Yeah, look, it doesn't really bend much, hey? It's not going to be a really strong correlation, but we can try that. All right, so it's sort of, I'm saying it's exponentially decreasing, so it's like going faster and slowing down. It's not good. It's not good. But that's okay. It's our data. So let's scroll down. Now I'm going to display my R² value. Now, what my R² value is, how much of this data can be explained, so how much of the number of possums can be explained by their proximity to a house. So what's really the influence of this house? So where am I? Go back, click on this bad boy again, and I'm going to go R². So R² is a value between 0 and 1. The closer it is to 1, the stronger that relationship is. Okay, so the more the data can be explained by the trend line. Now mine is super low, like that is pretty damn low, which means there's no real trend going on here. So I think I had to play around with ringtail as well, and I got 0.49 by adding in. What I did, I added in like a polynomial and sort of increase the number of, so like you can increase that, and you'll have to do that for yours. So that's how many times it sort of has turning points on it for polynomial. But if I stick to roughly my initial trend of exponential is what I think it actually does suit the best out of these lines. Yeah, it's not good. So I'm going to scroll down and I'm going to quickly edit because I actually said R squared value is 0.09. It's actually, that was for ringtail. My R squared value for brush tail is 0.1. I'm going to, maybe I should, yeah, 0.098 actually. So let's put that in, 0.098. Okay, so the distance as the distance from the houses increase, the number of possums decrease. However, the relationship is weak with an R square value of 0. Actually, I could even say, as indicated by the negative slope on the trend line in figure, let's call it figure 1, okay? However, the relationship is weak with an R squared value of 0.098, which indicates only 9.8% of the data for the possum abundance is explained by the proximity to the nearest house. Therefore, here's my bit of interpretation, linking it back to my research question, which I didn't do previously on the other one. Therefore, there's a lack of evidence to suggest a relationship between the two variables. And a low reliability within the data. That should actually be within. I don't know. Yeah, I don't know. Whatever. This may be due to the low sample size. I mean, maybe. Let's have a look at that. I think the real reason is the large number of uncontrolled variables. It could also just be that they are not influenced at all by a proximity to a house. I mean, I could have said that too. This suggests that they're not influenced at all by the proximity to the house. Once again, using this may be due to, this suggests that hedging language always to draw any conclusions. Alright, sweet, chill. That's the last video. Oh, you might have noticed I didn't actually need to use the data thing for this. I just used the graph. And obviously I'm going to fix this up and make it nice and neat. Like, for example, get my labels. How do I do that? Where's my... Your axes titles. Get rid of that title. Make it look beautiful. Keep your R squared in there. Make it look pretty. And, yeah, enjoy. Bye.